Hello, everyone. I hope you can hear me very well. So thank you and welcome to join here. It's nice to have such a concentration of people who are all so much interested in dedicating their efforts and resources to make our waters cleaner. And this event is to support all of you to accelerate your ideas. And let me introduce myself a bit. So I'm Arvidas, the ones who haven't met me. I'm innovation partner at Katalista Ventures. And together with my two great colleagues who both happen to have the same name, Greta, I will be hosting this event. And I will say a bit more about Katalista Ventures later on. But I would really like to start it by welcoming a representative of our co-organizers of this event, Rin from BaltCap. So to say why we're here. So Rin, the floor is yours. Please unmute, Rin, still.
Can you all hear me? Yes?
Yes, we can.
Okay, can you also see me?
Yes, we can see you.
Okay, good. I think it is a bit slow on my part, but then please just tell me if something is not working. So good morning and welcome to all of you to Clean Water Hackathon, also on behalf of the BaltCap team. And I'm very happy to meet you and greet you. And I must say it's exciting to see so many screens, so many distinguished experts from different countries, from different fields of expertise, all ready to hack the clean water problem. And just I'll say a few words.
It might seem crazy what I'm about to say.
Why? And why we decided to raise this topic and what do we expect from this hackathon. So first of all, the organizers, BaltCap with Katalista Ventures, and we are backed by NEFCO, we picked the topic to draw more attention and to raise more awareness about actually the oldest challenges in the world, how to clean water, how to get high quality water and how to preserve high quality water. And we believe it is a problem that has not received enough attention so far, and it deserves to get more public attention and to forcefully enter the public agenda. So I guess daily it is water scarcity and the quality of water. It is a topic that for many remains an abstract issue. It is not acknowledged daily. But then again, it is a stark reality to others. So first of all, we would like to raise awareness and have more attention to this topic. And secondly, we are here to create actionable impact, to create solutions that have both financial validity and also positive environmental impact. And BaltCap, as a private equity investment fund, is also eager to develop the market, to prepare our pipeline and to pave way for sound and attractive environmental investments. And actually, successful hackathons like this may have and serve as a very good platform to raise funding for different environmental projects. And actually, BaltCap, as an investor, is focusing also on sustainable investment and is very highly appreciating environmental issues. And just to say out, resource efficiency, climate change mitigation, and related projects are high in our investment focus. But what is the focus and aim of the current hack? Of course, to evaluate the scope of the clean water problem, back it up with some metrics, validate it, put the problem on the table of the responsible institutions, and find ways to solve the problem, and find out if there are economically feasible ways to to solve the problem. And why did we decide for a hack? First of all, to move quickly with a high speed. Secondly, to get out of the ordinary setting and habitual practices, and maybe even see this way the problem and the solutions from a different angle. Thirdly, of course, to gain network effects, to create synergy. We have participant teams from 3 countries, 5 from Lithuania, 5 from Latvia, and I hopefully now 2 from Estonia. We have mentors who will be mentoring the teams, more than 25 mentors from the Baltics, Scandinavia, UK, and even Spain to support the teams from public relations perspective, legal perspective, private equity perspective, etc. So network effects, synergy, and really boost the interdisciplinary approach. And lastly, as I already said, to create actionable impacts. So all in all, let's make most out of this unique occasion. It is the first time when we unite all 3 Baltic states and people working daily on preserving our waters. Thank you for joining us. Thank you for being here, and I hope you have a very inspiring and fruitful hackathon, and see you all on 29th of June, when we are going to take a look at the results and find out what we have found as solutions to this clean water problem. Thank you so much.
Thank you, Rin. Thank you for presenting BaltCap and also the aim of this hackathon. So just to kind of, we have also the slide to summarize these goals as well of the hackathon. So Rin already told it, I will not repeat myself. Maybe just one sentence about us, Katalista Ventures, co-organizing the event. So we are having 2 big activities. So one is we're early stage accelerator and fund for sustainable startups. And we're also working with existing organizations, helping them to execute their innovation strategies. And usually it's by connecting to relevant startups. So now I want to present our today's agenda. You can read it, so I will not repeat myself. So we will start with 3 short and super interesting keynotes. I'm super happy that we managed to collect all these people here. Just in one sentence, probably, the goal of these presentations is to understand the broader context, get inspired, learn something new, and get tips on financing your ideas. So you could be equipped to solve the challenge. So let me welcome our first speaker, Agne from Ministry of Environment. The floor is yours, Agne.
Good morning, everybody. I hope you can see me and hear me. First of all, I would like to thank organizers and also welcome participants on behalf of the Ministry of Environment. Today, 2 of us, me, Agne Knežaitė-Goffmanė, I am Agne Knežaitė-Goffmanė, working at the Ministry of Environment of Lithuania and dealing with all water-related issues, and also my colleague, Irmantas Valūnas, we will present where are we now in Lithuania with regard to water issues. Of course, I would like to thank for this opportunity to share with you and also to be inspired here in this unusual format, because it is very important for us to attract as much as possible wider public to water issues. As you very well know, that water is a vital resource for us human beings and also for our planet. So it's vitally important to preserve it and to have it, to leave it in a good status for our future generations and our planet. And in Lithuania, actually, we are quite lucky because we have plenty of water resources. We have a very good quality drinking water, which is mainly groundwater. and it is in a good status, and we have plenty of these resources. As regards rivers and lakes, here we also are a bit lucky, because at the moment our rivers and lakes are a bit higher than average EU. We have rivers and lakes in a good status and a bit a higher average than it is at EU level. But of course, the problems persist. And today, the main actually problem that we have, for me as a policymaker, the main issue is pollution from agriculture, because our rivers and lakes really suffers from excessive inputs of nutrients. And this is due to intensive agricultural activities, excessive fertilization, mineral fertilizers are used very intensively. Another issue that affects good status of our surface water bodies is hydromorphological alterations. Big number of Lithuanian rivers is straightened due to what is that word? Melioration, yes, melioration, and that affects the status of water bodies. Also, hydropower ponds negatively affects the status of water bodies in Lithuania. And we are trying to deal with this issue for quite some time by working with hydropower sector, also trying to construct fish passes in our Lithuanian rivers and also remove dams. But we are not so successive in those issues because the progress is quite low. Another issue related to water pollution is, of course, pollution from point sources and also diffused pollution from untreated individual wastewater systems. My colleague Irmantas will talk about that a little bit later. Also, the new but very hot, not new, but very hot topic is climate change that, of course, affects our water bodies and intensifies the problems that already are there, eutrophication and other ecological problems. Also, due to the climate change, we need to find new ways how to adapt to this changing situation. And also, as I mentioned, we have plenty of water resources, but still in Lithuania we suffer already from droughts and sometimes from also even lack of water for human consumption. Also, floods and are an issue where should we put attention due to the fact that climate change also affect that area quite a lot. Baltic Sea is suffering from this intensive pollution from point sources from the basin, from Lithuanian rivers, River Nemunas. As I mentioned, we have really significant inputs of nutrients, especially nitrogen and also phosphorus to the Baltic Sea. And Baltic Sea is a very sensitive environment, which is affected severely by eutrophication. So we need to put more effort to tackle those inputs of nitrogen and phosphorus and to reduce eutrophication in the Baltic Sea. And today in Lithuania, we are in the process of reviewing our main strategic documents related to water. We are in the end of one cycle, and we are reviewing the status, reviewing our river basin management plans, our strategic documents, reviewing the measures and actions that should be taken in order to achieve more progress in this area. And today we are hoping to hear from you and to maybe to be inspired or to learn maybe even how to use your ideas in our plans, and maybe how to use this or that kind of platforms to spread information about environmental and water related issues, and maybe even to take something from this one to our strategic documents, or maybe to our approaches how to deal with water related issues. So thank you and have a good good event, and I would like to pass the floor to my colleague Irmantas.
Thank you, Agne. Mm-hmm.
Hello. Well, so hope you can hear and see me. Thank you, Agne, for introduction of myself. And well, mainly I'm involved also. My name is Irmantas Lavunas. I also work in the Ministry of Environment of Lithuania, and mainly involved in the policy formation of drinking water supply and wastewater treatment services, and management of wastewater and requirements for the discharge of wastewater. So I'll give a brief overview of this field. Speaking about the access to water services, the current priority in Lithuania is to remedy the breach of the Urban Wastewater Treatment Directive, after which attention will have to be paid to settlements with a population that is between 200 and 2,000 personal equivalents. However, it must be taken into account that these residential areas of this size have their specifics. They are sparsely populated, they are far from each other or far from larger cities. They do not have the necessary infrastructure, or this infrastructure is outdated. So when planning to provide the water services in these territories, you must consider whether to develop centralized infrastructure or to apply other individual solutions, for example, separate wastewater treatment plans for each house or for group of houses, etc. Another goal is to protect the environment from the harmful effects of the discharged wastewater, and to ensure that this wastewater is treated in accordance with the established requirements. In Lithuania, about 24% of population treats wastewater individually. And according to the results of the state environmental control, statistically about 20% of these individual treatment plans do not meet the requirements. And also another we have challenge to achieve that all individual wastewater treatment plants by 2030 remove nitrogen and phosphorus compounds to the specified standards. Also currently, speaking about surface or storm wastewater, currently we treat about 16% of this wastewater. This is not to say that another part is all unacceptably contaminated, but also some risks remain. Currently, only surface water from the most polluted, potentially polluted areas is treated. In urban areas, as well as in the major Lithuanian cities, the surface wastewater treatment infrastructure is also outdated, and there are no treatment plants. As a result, most of the rainwater washed away from urban hard surfaces enters water bodies untreated. The government of Lithuania has approved the water field development program, and the core goals, some of them were mentioned by Agnia, but maybe just once more. These goals are to reduce pollution of water bodies from agricultural pollution sources, to improve the condition of lakes and ponds, to reduce pollution of water bodies from point sources, to reduce the input of nutrients that promote eutrophication to the environment, into the Coronial Lagoon, into the Baltic Sea, to reduce the release of hazardous chemicals into the marine environment and inland water bodies, to reduce the impact of marine litter that pollutes the sea and on the coastal and marine environment, to ensure that individually treated effluents do not pollute the environment, to reduce environmental pollution by surface wastewater, and better implementation of river basin-based management. So we believe that these challenges are common and relevant in all countries. We also believe that challenges can be addressed by innovative ideas. In this light, we appreciate the participation of the stylizers of ideas in this event, and are looking forward to see implementable proposals that would lead us to improving the status of water bodies and environment. Thank you very much.
Thank you, Irmantas and Agnia, and actually they will join also as mentors as well in our journey, as well as environment ministries from Latvia and Estonia as well. So it's a good overview, I guess, and good to have you here on board. And the second speaker we have is Anna Maria Oru, which is senior lecturer at the design department and University of Arts, and she will touch a very interesting topic here, biomimicry in sustainable innovation. So welcome, Anna, and the floor is yours.
Thank you very much. Good morning. Let me just set myself up here. Share my screen.
You have a beautiful surrounding, Anna.
Thank you. I thought since we're talking about nature, I'd like to sit out in nature just to inspire everyone. Can you see a slide full screen?
Yes, we can.
Naturevation. Hello, great. So let me just reduce this. Good morning. Thank you. So I'm so happy to join you today. And thank you, Greta, and to Katalista Ventures for the invitation to come and inspire you through nature as you depart on your fantastic challenge. I think nature indeed can be your design companion for innovation, for solutions, indeed sustainable ways of engaging the problem that you are trying to solve. And so this is going to be a rather quick run through the field and examples, but it's meant to spark your imaginations and your curiosity and give you a few ideas along your next two weeks, I guess. And so I call this journey Naturevation, innovating through biomimicry. For a moment, I just want to set the scene where we're starting from, and thank you to the environmental ministry for really giving us the challenge that is at hand. It's quite a large one that you're dealing with, but like you, we're all coming out of a lockdown. I'm actually sitting in Italy, and we are coming out of what was a headline by the UN environmental chief back in March. Nature is sending us a message. And actually, just yesterday in The Guardian, again, there was an article, Pandemics Result from Destruction of Nature, says the UN and WHO. So right here, we have both a responsibility and an opportunity to come out of this signaling moment and of nature, where we meet nature in another way and we start to view nature as a collaborator, as a co-creator, not only as a resource that we extract from or dump into. Yesterday, a report came out by the WWF on COVID-19, people and nature. And they warn that the risk of new disease emerging in the future is higher than ever, with the potential to wreak havoc on health, economies, and global security, as we've seen in the last few months. So we cannot return to business as usual. And I think we need to sort of do a complete 360 here. and we've gotten a taste of climate emergency that is at hand. And this is where we turn to nature. Nature has been around a long time. It has had a 3.8 billion years of research and development period, much longer than any of us. And if you were to take these 3.8 billion years and put them into a 12-month calendar, for example, just a small little mathematical equation, you would find that in March, the first life forms appeared. About 15 minutes ago, humans appeared on the scene. 30 seconds ago was the start of recorded history, and 1 second ago, the Industrial Revolution began. So humans are a relatively young species, still trying to get things right and actually getting a lot of things wrong. So it makes perfect sense to turn to nature. And this brings me to biomimicry. My very brief talk here will take you through 6 areas, and we start off with what is biomimicry, definition. So Janine Benyus from the Biomimicry Institute defines biomimicry as a new science that studies nature's best ideas and then imitates these designs and processes to solve human problems. Studying a leaf to invent a better solar cell is an example of this innovation inspired by nature. Janine Benyus coined the term in 1997 with her book, Biomimicry, Innovation Inspired by Nature. And biomimicry is very much concerned with developing sustainable solutions, learning the way designs come in form, processes, and system from 3.8 billion years of evolutionary testing. So here we can look at nature as a mentor, as a model, and as a measure. As a mentor, biomimicry is a new way of viewing and valuing nature. It introduces an error based on what we can learn from it, not what we can extract from it. Nature as a measure uses an ecological standard. After these 3.8 billion years, nature has learned what works and what doesn't. And of course, here we look at the planetary boundaries, living within the capital of the land and the resources that are available. And nature as a model is where we start to look at the different models that we can find outdoors. It emulates these forms and processes and systems and strategies to solve our challenges. So in biomimicry, we have 3 application levels: the form, the processes, and the systems. And I will go into these in more detail in a moment. There are 3 application scales, so a micro small scale, a mesa, an intermediate scale, and a macro, a large scale. And there are 2 concept types. And of course, you can use both. There's a literal conceptual application, which you emulate the original biology as closely as possible using technical details, or metaphorically. So you use a conceptual model from the biological inspiration in which you can distill out the main concept and apply it as a high-level idea to drive your concepts. So let's just go into each of those application levels, the form, process, and systems. The form is the visible shape or configuration, the 3-dimensional composition of something. It is the emulation of nature's form or function. It's about understanding the scale effects of something and the details of morphology, and in what context does a form function. Here, we look to nature for shape, inspiration, form, resilience, and so forth. Nature makes economical use of materials and achieves form through shape and design. These forms are incredibly efficient and of course have been designed over a long period of testing. In fact, Julian Vincent, from biomimetics professor in the UK, says in nature, materials are expensive and shape is cheap. So the basic strategy is less materials, more design. Using form on a larger level and as a source of inspiration, here in this project when I was working at Grimshaw Architects in London, we looked at how water droplets colliding and knotweed pollen on a molecular level, so looking at the structural components of it, has inspired one of the biggest set of greenhouses in the UK called the Eden Project. It's located in Cornwall, for example. Form on a micro level is of course also based on shape. And so I have been shamelessly collaborating with this tiny organism for many years now. since 2006 to be precise. And this is the Namibian fog basking beetle, and it has helped us to address several challenges, including water shortage. So many material water technologies have been based on his genius shell design. And this tiny fellow uses the bumps on his back for harvesting water from the fog that rolls off the Atlantic Ocean in the very early morning. This is how he survives. And nature has developed a very elegant scheme here for harvesting water from the atmosphere. You can look further into this, and it has to do with both the hydrophilic and hydrophobic properties of the bumps on his back and the shell, and how he gathers the water at his beak for early morning drink. This brings me to processes, just very briefly. Process is defined as the steps or actions that are taken in order to achieve a particular end, and might include perhaps a chemical reaction, a physical dynamic, a version of information transfer, or perhaps even a behavioral trait. The process level involves learning from the way that nature produces things or evolves. Here we look at what is the biological process, in what context does the function process, and how is something made in nature. I think one of the best process examples is temperature regulation by termites. And these guys were the first farmers on the earth. They have developed a zero waste sustainable architecture and solar air conditioning, and a greenhouse-like farming system. They have full control of their nests' temperature and humidity for efficient harvesting of a fungi food that keeps the entire colony alive. Their mounds, their nests, can always maintain a temperature within 1 degrees of 31 degrees Celsius, day and night, summer and winter, while external temperatures can range from -2 in the night to 45 degrees Celsius during the day. It's a fantastic example of animal architecture, and it has inspired a numerous amount of projects around the world, particularly in the construction industry. Here we have 3 examples. Back in 1996, the Eastgate Harara Center by Mick Pierce and Arabs, Council House in Melbourne, Australia, and the Davies Alpine Greenhouse by Wilkinson Air. It's a lovely small greenhouse that mimics the termite process. And this brings me to systems. And I think something that is very important in your challenge is this level of application as well. So a system or ecosystem addresses the larger context defined by the relationships and configurations amongst the components. This area examines how nature deals with things like waste and regeneration inside closed loop life cycles. It looks at what are the details of an ecosystem condition, in what context does the ecosystem function as well. And from a systems level, we see how nature creates relationships, collaborations in order to create common goals. And I think one of my favorite examples is systems collaboration amongst fire ants that self-assemble into waterproof rafts in order to survive floods. These fire ants, they link their bodies together to build floating rafts, and by forming this unbreakable and unsinkable chain, they float over the water in such a way that even the ants on the bottom of the pile survive. The colony survives, the queen survives. This is a great example, I think, of social biomimicry and social innovation in nature. And if you want to read further into this, Adrienne Marie Brown has written a book called Emergent Strategy. Another one of nature's social innovations are bees. And a book by Thomas Seeley called Bee Democracy investigates a very particular segment of leadership, social innovation, and nature that deals with democracy and decision-making. Seeley's studies into honeybees looks at bee behavior during a swarm process, and it looks into the collective decision-making process that happens that can have inputs into our own decision-making processes, one in which a collective behavior where bees succeed to working together towards to achieve shared goals. Highly recommended. And then we have, I thought I just threw this one in, which is Nature's Business Principles. The Business of Nature by Giles Hutchins looks into what he calls the firm of the future, which is based on 6 levels: building resilience, optimizing, adapting, integrating systems, navigating by values, and supporting life. A lovely project that we kind of used to illustrate some of these ideas is called the ABLE project. in the UK. It's also called the Cardboard to Caviar project. And systems can be applied to an entire symbiosis of a project in very multifaceted way. So in the ABLE project, this is a genius systems thinking strategy, which turns recycled cardboard into caviar. And it was started by the Green Business Network that hired Graham Wiles to think out of the box solutions of turning a very linear waste system into a circular regenerative systems. I think ecosystems can inspire us to change our highly wasteful production and consumption models. And this is the idea of systems thinking, where you look into a network of opportunities to view waste as a resource for all sorts of ecological symbiosis. So the challenge here was to move away from a linear design model, from conventional design practices and business as usual. So the issue was that packaged food items were arriving in restaurants in this area of Kirklees, Cambridge, and they were creating three waste streams: food, cardboard, and plastic waste. So Graham Wiles moved towards a circular design model where this requires innovative thinking out of the box and closed loop mappings. And these kind of systems mappings are very useful when you start to work on these kind of systems models. And so what Graham did, he took the packaged food stuff. So I'm just, I don't know if you can see my screen, but he took the packaged food stuff from the restaurants. He took the cardboard waste, he shredded it, he sold it to equestrian centers where horses are kept to be used as horse bedding. He noticed that when the shredded cardboard was mixed with the manure from the horses, it was perfect for wormery composting. He tried to sell the worms to a fish bait supplier who said there was not enough intake, there's not enough people fishing in the area. So he was stuck with all these worms. He took the worms, he started up a fish farm to breed Siberian sturgeon that makes caviar, which he sold back to the restaurant. So here you can see he took a very low value material, which is packaged cardboard, and turned it into a very high yielding material. This, of course, is a very small example of industrial ecology. And on a larger scale, you can look at the Kalundborg industrial symbiosis in Denmark that was now almost 30 years ago, I believe, started by a group of students. And it's a remarkable project because it took 5 large partners, let's say. There were 4 plants: a gyprock, an oil refinery, electrical power, and a bioplant. And of course, the municipal of Kalundborg, which mapped out all of the waste flows coming out of each plant, or what resources were needed in order to create a completely circular design. And this brings me to my final project, the Sahara Forest project, which works on all application levels. Scales and types. And this is truly a regenerative project and true to biomimicry all the way through. And it's an example of restorative design, creating new opportunities for biodiversity to flourish. And this is what I think the challenge is in your project, is you have to create a new kind of restorative future in terms of the water challenges that you are facing. The Sahara Forest project was in collaboration with Exploration Architecture, who I worked with in London, Charlie Payton, Bill Watts Engineers, and the Bellona Foundation in Norway. It's a positive collaboration. Both the team and the different technologies support each other and optimize each other's operating capacities. Every biomimicry project starts with defining a clear challenge. And so you have quite a clear challenge at hand, which is half of the job is done, at least 1/3 of it. What our environmental challenges here that we tried to address were water shortage, desertification, peak oil, peak phosphorus. And we realized that there was a need for affordable and sustainable means of producing water and food without reliance on our energy reserves. We don't have much time to go into this project today, but briefly, this is just a symbiosis mapping of the project. There are 2 technologies involved: the seawater greenhouse and concentrated solar power. And similar in an industrial ecology process, what we did here is we mapped out all of the inputs and the outputs from each of these technologies and what happens in order to create sort of a real systems symbiotic relationship in the project. So I want to leave you with a bag of goodies, a gift for your 2 weeks ahead, and some resources that you can use as you begin your journey. I think one big resource is that in order to learn from nature, we have to find ways and time to be with and in nature. I became a beekeeper about 5 years ago, and this world has opened up so much to me about working towards a common ecological good for the greater whole. I use it very, very often in my teaching. I'm senior lecturer at the Konstfack University of Arts, Crafts and Design in Stockholm, Sweden. And we're actually getting bees to put on the roof of our university this year. So it's engaging with nature is really, really important. There are so many wonderful books. When I began on this journey back in 2003 into biomimicry, we had one book, almost, Biomimicry, which is innovation inspired by nature here in Janine Benyus, that was published in 1997. Here, Michael Polin, who I worked with at Exploration Architecture, we came out with Biomimicry in Architecture, and a lot of the projects that I have spoken about today are in detail in this book. And then you have the whole world ahead of you. You've got how to be inspired by swarms, by octopuses, by the mechanical advancement of organisms, anything. And a wonderful resource that has been developed over the past 20 years by the Biomimicry Institute is this asknature.org. So you can just go online, it's for free. And here I've taken the liberty of typing in your challenge, water clean. And so you just type in your challenge here. And what will happen is that it'll bring you to a page of, you can spend hours on this and lose much time, but it'll bring you to a page of wonderful ideas that you can tap into and read into, and functions and living systems and so forth. And I just went into one here because one of my students for the Biomimicry Student Challenge competition used the baleen whale, the jawline, and the way that the whale that filters food through it into its internal area is a wonderful, they used it for microplastics in the ocean, cleaning up microplastics, so that you can really tap into all sorts of ideas. And you can look at the Biomimicry Institute Life Principles. That's a wonderful biomimicry design lands here in 6 areas: evolving to survive, being resource efficient, and so forth. The Biomimetic Ontology by Julian Vincent is also very useful. The Tapping Nature report for different kinds of industry and sector realms, you can look into that. And finally, 2 years ago, I worked on a publication called The Biomimicry in the Nordic Countries. And though it was mostly mapping of actors in biomimicry and biorelated fields in the Nordics, I also put in the EU. So here you can read the report, it's for free. You can download it from the internet. You can look into biomimicry further. We did a SWOT analysis as well, and different categories of findings in the different industry sector. But whatever tools or strategies you use on your sustainability journey, I think one of the main aspects here, and I leave you with this, is to create conditions that are conducive to life. And I think with biomimicry at your side, you can certainly do this. Thank you very much for listening. I hope you enjoyed that.
Thank you, Anna. It was really nice, and yeah, I have no doubts. Many teams got inspired by your presentation. So do I. So thank you a lot.
It's my pleasure. Good luck.
Yeah. Yeah. Thank you. And now I want to present the final speaker today. It's Dennis from NEFCO, or Nordic Environment Finance Corporation, who will briefly talk about financing the implementation of your team solutions. So Dennis, the floor is yours. If you will not be able to show slides, we have it, so let us know.
Perfect. Thank you very much, Arvidas, and thank you very much for the previous speakers. Really happy to having been part of this, just if not only to hear these very inspiring talks. I see that my presentation is up here, so it's this is great. If you can then deal with moving it from one slide to the next. We can go to the next slide right away. My name is Dennis Amrudrots, and I work for the Nordic Environment Finance Corporation, which is a international financial institution owned by the Nordic countries that was set up in the early 90s already. And what makes us special is that we only finance projects and companies that have a solution that improves the environment in one way or another. Here you can see probably the key challenge of the Baltic Sea, which is eutrophication, too much nutrients flowing out into the ocean, creating these algal blooms that is detrimental in many ways. In particular, if you are spending holidays or time by the ocean, but of course also for the ecological environment in the Baltic Sea that are suffering. We have a lot of sea floor that is completely deprived of oxygen, creating a vicious circle where today the internal load of the Baltic Sea is one of the key challenges yet to be addressed. Previous speaker mentioned the key challenge, which is runoff from agriculture, and in addition to that, there's also this about the internal load, where we have already a lot of nutrients in the Baltic Sea proper that is then additionally feeding these algal blooms. We at NEFCO have been working with Baltic Sea related issues and projects for about 30 years. We also have several projects in the Baltic countries, mainly related to wastewater treatment. 10, 20 years ago, there was a lot that was being done to improve these point sources where there is a lot of nutrients or toxics coming out from point sources, be it then factories or cities, etc. But a lot of these have been now taken care of, and now we are looking more into also agricultural runoff, and then, as I mentioned, this up and coming topic about the internal load. Next slide, please. I'm here having a quick kind of overview on some of my thoughts about the type of projects, and then also raising the point about thinking about how to finance these projects. And also, ideally, of course, a project should in the long run be able to finance itself, because that is the key way to being able to grow them, make them bigger, and make them sustainable, because rarely a project survives in the long term if it relies on only getting money from the outside through grants. But we have various types of projects. We have academic research, understanding the problem, coming up with potential solutions. Following that, you can have small-scale pilots, maybe even, first in a lab, and then in a small scale in a lake or a smaller river, or then out in the ocean in a bay, and then eventually maybe even out on the open seas. And that is where you come into these larger scale pilots and demonstration projects. Following that, hopefully at some point a project becomes a commercial scale project that is also what I call bankable. That is that a bank would be willing to actually finance it through loans, seeing that there is a potential to get the money back eventually. And lastly, when we talk about the Baltic Sea or any ocean, is projects addressing the large scale problems that exists also out on the open sea, where the areas and the scale of the problems are quite different than when you talk about the confined water basin. Next slide, please. And as you see, I'm coming back to this one picture to kind of get that one stuck into your memories when you consider the various solutions that you are about to come up with. Next slide, please. Here we talk about different type of financing instruments. For academic projects, it is usually research grants. Then you have project grants, and both of these can be called, this nice money. So that is money that you get and you don't have to pay it back. That is quite often needed to get things started. When things gets rolling, you might still find this type of grant money, but usually there is also a need to have some joint financing from some other financier. You wouldn't get 100% grants. Then you move into loans that eventually would need to be paid back in one form or another. And then there's also financing, of course, coming from companies, private equity funds, venture capital, etc. And as a last point, there are these, for example, challenge funds where someone is then a government, or it can be a municipality, or it can be a private company that has some kind of campaign. They set up a challenge. For example, we want we want a solution for problem X, and then the best solution will win a prize and be able then to implement it, for example. But this is kind of a very kind of brief list of different type of financing instruments available for the type of projects we are talking about. Next slide, please. And I just have one case study here in respect to a financing instrument that is related to NEFCO. So you can take the next slide. And this is the Baltic Sea Action Plan Fund, which is a fund set up 10 years ago to co-finance projects in the Baltic Sea area addressing the various environmental challenges that exists. And this is money that have come in from the governments of Finland and Sweden, but has been available for any projects in the Baltic Sea area that address the environmental challenges in the Baltic Sea. So there are several projects, for example, I think in Estonia related to wastewater treatment. We have some in Russia related to toxic waste, and then we have some projects in Finland and Sweden ranging from biogas to alternative fuels, to agricultural novel agricultural solutions, as well as a couple of projects looking into this problem of the internal load that I mentioned previously, that are activities taking place out on the sea. One was looking into deep water oxygenation, and another one was the removal of nutrients from the bottom sediments, kind of vacuuming up the topmost centimeters of sediments to get the phosphorus out of the bottom sediments and hopefully at some point back to the fields where they are needed for plants to grow. Still very small scale pilots, however. This fund is in the category of nice money, so that is grant based, but it also requires from projects that they have some kind of additional co-financing available. But this, for example, is an example of a fund that could be a possible financing instrument for your projects eventually. And next slide, please. So challenges and next steps, and that is the final slide. If you take the next slide, please. And this, I think, is something that is good to consider from the start when you look into the type of projects that you are planning. How could your projects be scaled up eventually? You also always need to consider what are the financing options available. Are there money? Is there money available for your projects, both in the small scale and then eventually in the large scale? And when you talk about the Baltic Sea, multiple countries, you also should take into consideration political will. Then the Baltic Sea still faces a lot of challenges. There are a lot that remains to be done, but ending on a positive note and hopefully inspiring you with your projects, this means also that there are many opportunities that still exists. So I also wish you good luck, and I'm happy to be part of the process. I will be also acting as a mentor to some of you, and then part of the jury at the end of this hackathon. Thank you very much.
Thank you, Dennis, for presentation. Yeah, Dennis will be one of the mentors. So for the teams who want to know more, I mean, you have an opportunity to talk to Dennis directly as well. So yeah, so hope you were inspired, and actually very different messages probably we got, and I hope everyone got something interesting for themselves as well. So now it's time to reduce your enthusiasm a bit. I'm joking, of course. So now it's a bit different time. Until time when I will present relevant information for the hackathon. The process we will be working, I will be super short, and all the information I will be presenting you will receive later on within your mail. So you don't need to make photos or try to grab these links I will show, but just kind of just intro what you will have, okay? So yeah, first of all, as you probably know, everyone, it will be 3 steps of this hackathon. So first one is today. And there are 3 kind of things we're doing today, kind of main things. So first of all, yeah, all these kind of talks you heard already, and the presentation from other teams to get inspiration, some extra ideas for yourself. Other thing is to meet other teams, and please kind of listening to other team presentations, which will be shortly, think about how these teams could also kind of help you, and at the same time how you can help these teams as well. So it will be the starting point. After the starting point, from 18th to 29th of June, the second step, you will develop your solutions. You will meet mentors and get extra help. I will introduce it shortly. All of you will be invited to have one-on-one meetings. Some of them did that already, so the ones who didn't, please do it. And we will have a plan. And the third one, the last one is Hackathon Day, 29th of June. So the idea is to pack your solutions as best as possible, get some more mentors, and present them in a way that everyone could understand it in the best way possible, and you could get way forward afterwards, either with funding or with kind of mentors or with partners or whatever you need after the hackathon. Okay, and so 4 things, just kind of you will receive shortly. So first of all, book one-on-one meetings with us, Katalista Ventures. It's a link. All the teams receive this link via your emails. If you haven't, please write us again, and we will resend it. So please fill. We still have time. So these one-on-one meetings for today and tomorrow. And the goal, as I said, is to set up a plan, goals, and best fitting mentors for your team to progress as fast as possible and to do as much as possible. The next thing is Slack platform. So you will all receive invitation. We decided to kind of work in this platform because we can create different rooms for the teams. We can kind of communicate you all the messages. So usually emails are not the best one to do that. So we will invite you shortly to this channel and explain you everything there, how it will work. So it will be quite easy. If someone haven't used the Slack and will not be able to join it, please let us know, and we will help you in that journey as well. Okay, and third thing, it's a Google Drive there as well with all the information. So file for mentors, file for the teams. We have also extra things as well there. So, link is yours, and you can use it as you want as well. And the last thing, but not the least, to book a mentor, we create a system when you can do it, automatically yourself. So, you can go to the mentor sheet, you can check what mentors are, most suitable for you. You can, on the link, you can see the availability, and if you kind of, book with my meetings online, and you will receive invitations. So super easy, super simple. If you don't know yet which mentors to choose, so we'll have one-on-one meetings for you to help you as well. If you have your choice before, so you can book them straight away as well. And we have, as Rino already told, many mentors, so 25 so far, and still more to come. So it will be enough mentors for everyone. And one more thing we wanted to emphasize. So we see that, teams will be a bit different here. So one of them will develop a solution from scratch or from quite early stage. Another ones will go with scaling the solutions. So we prepared for both teams, and we will kind of guide you also in both journeys, kind of both scaling and developing the solutions. Okay, and the hackathon itself, agenda is also in this drive as well, so you're able to see it yourself. We kind of we'll have a few speakers. It will be quite intense. We'll have 3 different mentoring sessions. So it will be pitching, it will be business modeling and legal regulations. We have mentors from all over, also Europe, so it will be a great time as well. And that's shortly about the hackathon itself. And now one more thing, prizes. So definitely the main prize here is for you to develop your solutions. We hope so, but we have more to come. So first of all, the NEFCO, the Dennis presented this kind of opportunities of funding as well. So the best 3 teams, will get fast track to NEFCO kind of funding pitching. So you will be able to kind of go and directly pitch to NEFCO fund, which is, I think, super valuable possibility here as well. First 2 teams also will win a valuable online course for the team. Let's make it as a secret. We have it, but we want to make it as a secret, so we will not announce what kind of training it will be. And also teams will receive consultations from both Katalista Ventures and BaltCap, different amount of hours depending on what kind of place we will take. But all in all, we wrote here that 6 kind of teams would get some prizes, but we believe that all teams will get reward after this hackathon. So, and even to be honest, I can also give say some secrets, so it might be some more prizes as well on the way. So stay tuned on that one. And yes, now it's showtime for the teams. So the rules are as follows. We will have 5 minutes for each team, and my colleague Greta will have a stopwatch. So if you will kind of have more time than 5 minutes, we will let you know and try to kind of finish this presentation, as we have many teams. So we want to kind of not take all day long today. And in the best way, it will be 3 minutes for pitching and 2 minutes for Q&A. For Q&A, please write your questions to the chat, and then I will be able either to ask them or direct you, so not to have to kind of lots of noise there. If some questions will be unanswered because of due lag time, we will forward these questions either to the Slack system or it will be from mentors, so we can manage that way. So okay, let's start. So first of all, Ekodrena, Jonas, the floor is yours.
Thank you, Arvidas. Can you hear me and see?
Yes, perfect.
I'm trying to share the presentation. I hope you see it.
Yes, we see it. Just make it full screen if possible.
Yeah, and 1 second, we will have sound on this presentation. And I hope you will.
When you are sharing the presentation, it's an option to share with a sound before sharing.
Okay, then I will stop share for a second.
It's in the corner at the bottom.
Yeah, I see it. Thank you. Can you see it again?
Yes.
Okay. Thank you so much for inviting me. usually when we are invited to some forums to talk about it, we speak about 1 hour. So I'll try to be as fast as possible, but I'm not sure how I manage with the time. Jumping straight forward to the topic we are working on. As Agne and Dirmant has mentioned from Environment Ministry, we have and also as Dennis mentioned, that one of the biggest problems in Baltic Sea region and surface waters is the eutrophication processes. So this is a natural situation for the nature when so many nitrogen is coming to the surface waters and they start to be, as we know, green and unstable and not in the way the nature was designed. And when we looked at this challenge, which we accepted for ourselves, we said, wait a second, do we deal with the eutrophication as such, as a consequence, or do we find the real reason why it's happening and try to fight with those reasons, not only with the consequences? And what we found out, what we understood, is that nitrogen is coming from agriculture activities. And we could purely say, okay, so then the farmers are the bad guys and let's do some restrictions on them. Let's not allow them to put this nitrogen into the ground, which eventually through drainage systems flows into the surface waters. But on the other hand, so who's going to feed us? Who's going to feed the planet? The increasing number of people in our planet. So on one hand, we have a problem that eutrophication processes are faster and faster, and we have worse and worse situation. Farmers are always called in the press as the main polluter of surface waters in Baltic region. On the other hand, we still need to use those nitrogens to get as much food as needed for our society and for the world. And moreover, for the farmers, there's additional stress because the climate change is changing, and we have drought each spring. So what to do? What to do is the solution which we created, and short clip for that.
JAV ir Kanadoje nuo 2010 metų modernizuojamos drenažo sistemos, ko pasekoje reguliuojamas gruntinis vandens lygis dirvožemyje. Priklausomai nuo oro sąlygų galima sustabdyti drenažinio vandens tekėjimą iš laukų arba leisti vandeniui tekėti laisvai. Pažiūrėkime, kaip viskas vyksta po žeme. Nuėmus derlių, kuomet nėra didelio pavojaus dėl užmirkimo, drenažinis vanduo yra sustabdomas ir gruntinio vandens lygis yra pakeliamas. Tai sulaiko trąšų išplovimą iš dirvožemio ir pagerina jo savybės. Pavasarį, prieš apdirbant laukus, gruntinio vandens lygis yra pažeminamas, kad technika galėtų įvažiuoti į laukus ir būtų išsaugomas maksimalus drėgmės kiekis dirvožemyje. O atlikus darbus, drenažo ištekėjimas vėl sustabdomas, kas gali padėti pasėliams gauti daugiau vandens ir trąšų. Reguliuojamo drenažo sistema ekodrena suteikia galimybę sulaikyti drėgmę dirvožemyje bei palaikyti vandens lygį prie šaknų zonos, net ir tuose sklypuose, kurie nėra lygus. Pažiūrėkime, kaip ekodrena sistema veikia tuomet. Įvertinę esamą situaciją, mūsų specialistai suprojektuos ekodrena sistemos išdėstymą taip, kad vožtuvų pagalba vandens lygis visame sklype būtų sulaikomas prie pasėlių šaknų zonos. Vožtuvai veikia automatiškai ir jų reguliuoti nereikia, bet to jie įrengiami po žeme, todėl visiškai netrukdo technikai darbuotis laukuose. Kontroliuojamo drenažo sistema ekodrena. Sausinkime tiek, kiek būtina ir nei lašo daugiau.
Yes, so basically we have a solution which is a win-win technology, as we call it, because we can both be sustainable with the nature and stop nitrogen flow out to the surface lakes and then rivers and eventually Baltic Sea. You see the numbers on the left yourself, how much ekodrena already has stopped of leaking of nitrogen, but there is much more to do. Moreover, it's very good for the farmers because the nitrogen stays in the fields. It helps crops to grow, and moreover, they have a lot of humidity, and they are not afraid of drought. Where we are right now is we have 41 farms which already has installed to some extent regulated drainage in their fields. There are first customers coming who are making whole farmlands like 700, 2,000 hectares with regulated drainage. We just signed the contract with one of the biggest agro company in the Baltics, Nova Baltic, who will help us on selling and scaling in Baltic states. That what we basically are looking for and why we are attending this hackathon is two things. One is scaling to the whole Baltic Sea region, as we don't know yet how to do that, and we will be really happy to get some advices. Another thing, as I have a chance, I would like to maybe ask instead of answer and give a question for Agne and Irmantas from agriculture, from Environment Ministry. I know there's a program who finances farmers on changing from typical regular drainage to regulated drainage, but we are waiting for half a year already, and the farmers are waiting so much for the rules, how this will be funded and how they can apply. I know that APA, Environmental Project Management Agency, has announced this already, but not the rules. So everybody is waiting really, because we have to do it now. We cannot wait. The nature will not wait.
Thank you, Jonas. Sorry for taking, I mean, it took a bit more time of that one. So yeah, we will somehow punish you later on. Joking, of course, Jonas. Thank you for your presentation. So I guess, you said what you were looking for, and yeah, we will be able to find this mentor. So thank you, Jonas, a lot. And let's move to another one. So actually, we wanted to make one change here, and Valerie and Donata's team, to put them the second one, because we need to leave a bit earlier. So if you could join right now, and thank you, Jonas, again for the presentation.
Thank you so much.
Are you ready, Valerie and Donatas?
Yeah, can you hear me?
Yes, we can.
Okay, I see that I have some kind of the security warning that I cannot present anything, but anyway, we don't have slides, so probably I'll just introduce myself and Valerie a bit, and Valerie will continue after me because I have to run to another meeting, so sorry about that. So we just met yesterday with Valerie, so we are a fresh team, but we had the same idea how to monitor the water bodies, basically the pollution. Because the problem we saw that it's quite easy to pollute the water and hide the source of the pollution. We had some scandals in Lithuania, for example, like with the company Grigeo, when the pipe was opened at some moments and it went unnoticed for a while, and the harm was enormous for the nature. So our goal is to have a platform which could provide the information for ordinary citizens about the water bodies pollutions, and to raise the awareness how the situation is changing, and if it's possible, for example, to drink or to swim in those water bodies. One of our idea is just to have satellite imagery and analyze it and provide some kind of the insights, and probably to have some numbers for people. This could also make a pressure for governments. For example, if we see that if the public sees that that this information is trustworthy, and that if the situation is getting worse, better or in a bad direction, I think the citizens can make some big impact to the governments. So this is my short presentation and my ideas. Maybe the next could be Valerie and add more about our project.
Yes, hello.
Hello.
Yes, I can continue. So then, like Donata said, like we want to tackle water pollution and try to use local pressure to also then help with the government regulation. But we want to make a platform that can analyze any water body. So the idea is maybe to like we said, we don't know yet what the best data source to use is, but for the moment, our idea is to use satellite data. And then the idea is to be able to just have the data presented in a very easy to understand way so that anybody can read it, not just people who are data analyzers, for example. And then the idea is to create either a website or app that people can subscribe to or download that allows them to type in a water body and then see the pollution levels or get a warning, for example, when pollution levels increase or there's a significant increase, and that hopefully will also help to understand when, for like an industry decides to just dump like their wastewater into water streams or something. At the moment, it's not super detectable, but with this, hopefully it would be able to help. And the idea is to also do this kind of by specific zones, but we're still developing because like Donata said, we just met yesterday and we're just starting. But yeah, so the idea is to basically create a platform that people can visit, and then a website or an app. So we are looking for ideas and expertise about the best kind of data to use for this, whether it's possible, and then people who understand like what is needed for these kind of things, like someone who knows how to process these kind of images from satellite data, or the front-end developer or mobile app developer, people who know these kind of things. And yeah, that's all I have to say.
Thank you, Valerie.
Yeah.
We got some fresh ideas are coming to the stage as well, and we're discussing with BaltCap in the beginning even, this kind of vision. We want to build some kind of solution actually in the end of the day, of even maybe after this hackathon, to combine all the data information. So I hope you are succeeding here. Thank you a lot. And then let's move to the third team. So it's Fungi, actually from Latvia, yeah? So please, the floor is yours, and yeah.
Good day, everyone. Greetings from Riga. We today have a really sunny day here, so it's super hot. My name is Brigitte Delecka, and I'm from Team Fungi. Total, we are 5 members of team: Gins, Davids, Sandis, me, and Antons. And we are presenting Riga Technical University Water Research Laboratory, and we have prepared small video with our pitch. So give me 5 seconds and I will share my screen to show this video.
Just also add this kind of option, the voice. It will be then.
Yes. Let's take this one. I hope it will work.
We hope too.
There is some kind of problem. Maybe I know that I also send you a video. Maybe you can share this, because I don't have option that I could share my screen.
Okay, so I guess we can do it. Just a second, okay?
Yes, I'm really sorry, but
intro, so you can do it, or just video.
Just video.
Okay.
Yes. Great. Yes.
Thank you. Nice video.
Yes, that's all from our side. So we are looking for some mentors and advice how to optimize our bioreactors. So we are looking forward to get this.
And what about business perspective? Are you also looking?
Of course, we are open for everything. Also for submitting some projects.
Nice. Thank you, Brigitte. Okay, so yeah. Next team, one moment. Yeah. Check what is next team. It's undam. Damn it, yeah. Undam it, probably, yeah.
Yeah, hello everyone. I'm Yeva and I'm from Undamned team. So we have 3 of us. I will try to share the screen and the presentation. Can you see it?
Yes, we can.
Okay, great. So I hope it will be 3 minutes or even shorter. And mostly I will present the challenge, because for the solution, we are hoping to develop it during the next 10 days. So my name is Yava, and together with Jona, we are project managers of the program called Create Lithuania. And at the moment, we are working at the Ministry of Environment with a project on a dam removal. And we also have another member, which is Karolis, and who is a creative team of member, since he's working in creative industries. So what is the dam problem? So dams were mentioned also by Agne Knežaitė Goffman from the Ministry of Environment. So we are causing ecological problems, but also socioeconomic problems. Dams add to degrading quality of water, and they are also obstacles to fish migration, and also cause radical changes in river ecosystem, accumulate sediments and pollution, and so on. But also from a socioeconomic perspective, dam is not such a great thing, since dams pose accidents that pose risk to lives, property, and environment. In Lithuania, there are around 1 to 2 accidents every year related to dams. And it's also cost for municipalities to maintain dams in a good condition. And also because of the dams, for example, some migratory fish species have been endangered, and because of that, the artificial breeding of these fish species is going on, which is costly, and as research shown, is not really economically effective. And of all the dams we have in Lithuania, around 96 are small hydropower dams. And even those that have function are not very efficient, since they produce around only 0.5% of energy created. So dam is not a very great thing these days, especially obsolete dams that do not have functions anymore. And in Lithuania, we have, it's estimated that we have around 1,500 variety-sized dams. Many of them are old and not functional, so obsolete. Some dams don't have owners, so technically we don't even exist. And what we also see that there is a lack of general awareness in the public of what does a dam mean to a river. And as some examples of projects shown that communities show great attachment to dams. And the solution, one of the solutions for the free-flowing rivers and dam problem is a dam removal, which is already practiced in Europe and in USA a lot. And number of dams removed in Europe reach nearly 5,000, but in Lithuania it's still a very new concept. And at this moment we have 0 dams that are removed in Lithuania, although we have 2 projects that are coming up soon in the near future. So in our project, where me and Jona work at the Ministry of Environment currently until September, we look at the challenges to the dam removal. So we look at the challenges of systemic dam removal, lack of systemic dam removal process, lack of institutional collaboration and legislation. But there are also other challenges that we would like to tackle during this Clean Water Hackathon, which are lack of general awareness about the issue and disapproval of such projects by the local communities, owners, and other interested parties. So the last two challenges are the challenges we raise for this hackathon. And as for solutions, we are hoping to develop it during the hackathon, but I think Jana can present a couple of very fresh ideas that might or might not be implemented later on. But maybe Jana, you can just present a couple of fresh ideas now.
Okay, thank you for presentation. I can just spitball some ideas. So we're using Hackathon to get to know some people who are really good in communication and marketing maybe, and we need to find a way how to present this topic to the public so they would understand and they would get on board. So maybe creating some sort of brand, a platform, a game. Yesterday, me and Katalista were just spitballing ideas, and we thought of all kinds of interactive games that you can do with your smartphone, maybe some sort of something based on a local community, so people can play and see, okay, this is my town, that's really weird. And then maybe scaling up to like the larger, throughout the whole Lithuania, so people can play in maybe their communities and dams that are involved in that. So we were also thinking about involving public figures, known people who can maybe persuade people to think about the fish and what's happening under the water. And I'm not even sure what else we were talking about, but all these kind of ideas that we're thinking of developing later on.
Thank you for quite great presentation as well. Looking forward to help you in this journey as well. And yeah, maybe I will take also some time here just for all the mentors. If you feel listening any team, you can support them. So please kind of do it. I mean, there are teams kind of, sheet team kind of Excel and we all share the view, so you can go and connect with teams as well yourself. So thank you, the team. And the next team is, and the next team, 1 second, is Musha Clan. So the floor is yours. Sounds very interesting, team name. Do we have someone from Musha Clan? Maybe some technical issues. Just kind of, maybe we can move to another team and then we will leave Musha Clan for the later on. So is Litmus team? Is it here?
Yes, we're here. Let me share the screen. Hi. We're very glad to be here. I'm Audronė, and we're a team of Elvira, Justas, and Kristina. We're not water experts, we're more environmental, sustainability, and ecosystem experts. And the inspiration to participate in this hackathon came from Žuvintas Lake, because we see that this lake situated in Dovine River catchment area is really unique. It's important not only for Lithuania, it's really very important in a global scale. However, the reserve is under heavy pressure of leaching nutrients, and mostly from agriculture, as we know already. And that really influences ecosystems and their values, and of course the biodiversity of the place. So what we know, that pollution is here, but what we don't know from where the pollution is coming. And we have been working already nearly a year within that area. We set even a small local monitoring already, and we're talking to different stakeholders, farmers, local communities, municipalities. And it's still not clear from where precisely the pollution is coming, because there is lack of effective, comprehensive, localized, and continued monitoring system of water quality in this really sensitive catchment area. And we think that the collaboration with different stakeholders is essential, because of course we have to have the technical solutions. We may employ biomimicry, we may employ a number of different methods, but first of all, we have to know from where pollution is coming. We can't manage if we don't know from where the problem is coming. So what we want to suggest, and what came to our mind, it's to employ citizen science and to add water quality data, to fill water quality data gaps, and empower citizens to participate in water management. We think that it's very good implementation, a very good tool to encourage participation in Water Framework Directive. We know very well that such apps does exist. Of course, those apps are limited. They measure, for instance, only nitrates. But we think that it might be quite different. We know it works. Why not in Lithuania? And why not with more parameters? We're at the very, very beginning because we are not neither app developers, neither we're able to create the different solutions for the developing different analytical part of the parameters. But I think this app might really to help to analyze surface water and groundwater. And it might also encourage to isolate sources at hot spot. And I think we may test the impact of different technical measures, what might be provided to solve those pollution problems. So we want to talk about prevention, not about end-of-pipe technologies. And basically it's an app. And we know that it worked quite well, and it's loved in Scandinavian countries by farmers, water authorities, water companies. We are not sure about commercial part of that site, but we believe that we may develop it. And of course, we're looking for the app development. We need to work with the water quality parameters. We need some maybe more assistance on how to involve citizens. And yes, and we're very happy to participate here. Maybe my colleagues could add something.
Thank you. Maybe just kind of, the question probably, if we still have a bit of time for you, what kind of help or resources you would need for the hackathon from a mentorship point of view?
I think first of all, we have to think about the app, because we are not app developers, and we're looking for the fifth member of our team, and we have somebody in mind. And of course, probably the advice from the Ministry of Environment, how we may fit into the Water Framework Directive implementation, because we have a feeling that it's very needed. And also we would need the analysts of the parameters, so scientists who would help in identifying, because we know that for nitrates it's quite possible and it works, but maybe it's possible for phosphorus and for other parameters. And of course, commercial part. So we really need a lot of help.
Thank you, Donovan. I guess that everyone from mentor side also can collect that information, and you also will be able to go to see the mentors as well. So thank you for your presentation. And now it's time for the next team. It's Blue Marine. So Blue Marine team, are you ready?
Yes. Hello.
Hi.
Hi.
Surrounding. Are you in US?
I want to be, maybe. Yes. I'm gonna start sharing the screen, I think. And just 1 second. Yes. So first of all, I just wanted to thank you for the opportunity to Katalista Ventures and BaltCap, and we are really excited, and we have been listening to all these new ideas, and it feels really great. In our team, we have me and Marina Ogay. So I'll be presenting today. So our goal is basically to find solutions for the marine pollutions that are caused by these cargo transportations or the passenger ships, and how we can purify the water of Daugava River in terms of improving the health of the people who usually go for swimming in these areas. Yeah, these are one of the common marine pollution causes, such as oily water discharge, tanker accidents, anti-fouling paints, and wastewater discharge. These are some of the pollutants released into the water bodies, such as the oil spill in Russia, or the litter, as you can see, the dolphin biting on, or the anti-fouling paint that is provided on the big, large tankers, which essentially prevent from corrosion, which actually tends to leach into the marine water and actually kill bacteria and essential bacteria and do more harm to the environment. This is a statistics of a traditional tanker and how its consumption affects the water pollution. And here is the statistics from Central Statistical Bureau of Latvia about the recent passenger travel that has dropped from the last fiscal point of 2019 till the first fiscal year point of 2020, where the passenger footfall has severely dropped, which has caused a tremendous rejuvenation of the marine environment. Whereas in Liepāja port, there has to be some kind of update. The present day methods of the water purification we have is the activated carbon filtration. This method can be used for removal of fuel and dioxin and radioactive waste. There's also air stripping, which can easily evaporate fuels and solvents. And Technopure is a solution, is a company that we have found that helps removal of water through essentially non-chemical oxidation, and it helps destroy the algae that has been floating throughout the water and creating much damage. There's also nature's methods of recovering, such as bioremediation, that uses the biomicroorganisms that naturally are found in the soil. And these processes generally take a lot of time. So it can be difficult for the environment to correct itself with the amount of pollution that the humans cause at all times. The support we need, essentially, because we are a new team and we have just started in this endeavor, is more research and more assessment, and to bring in the environmental impact assessment, where these methods can be put on a proposal and be given for the agreement. And as I mentioned earlier, and in Technopure is the use of ionization for cleaning the water in Daugava River. And further, more statistics from the Central Statistical Bureau of Latvia. That's our presentation. Thank you.
Thank you. Yeah. Good presentation, nice presentation. So good luck with working in this hackathon. And let's move to another team. Okay. So as the time is pressing guys is also, so I guess that Musha clan now is very ready to jump and present. Maris?
Hello, hello.
Hello, it's quite noisy.
Hello.
Can you check your microphone?
Hello, hello.
It's a bit of noise in backgrounds.
Hello.
Maybe that. It's, we can't hear anything. Maybe someone else from your team can join and present.
Oh, hello, 1, 2, 3, 4, test. I have quite poor internet connection code. Hello, 1, 2, 3, techno.
Actually, we can hear. So let's move right now the next team, and later on we will be able maybe to figure out. And please, if we can check one more time, just sound maybe without video, it could help as well. So let's then move to another team just to save a bit of time. So time to change, right now.
Hello everyone, we are a team called Time to Change. Today we are 3 here, 2 of our members are not here today. So I was chosen to be a volunteer to present to you our ideas and what we are aiming here. We are representing Klaipėda University and Marine Research Institute. And as researchers and direct observers of nature and the problems you all mentioned today, we do not have a luxury of 3.5 billion years, which was mentioned today, in our problem, which we want to address during this hackathon. So if you see our picture, we want to generally repaint the picture, because from our experience in observing the nature and observing the Coronel Lagoon and marine areas of Lithuania, we see a rising gap between the established perception and presumable reality of pollution and interaction between humanity and the nature. And the main goals we would like to, main objects through which we would like to present this rising gap is the emerging pollutants, so pharmaceuticals, artificial materials, and of course not forgetting the nutrients. So the exercise or the game rules which we want to apply for this hackathon is to try to compare, as the scientists usually do, try to compare different scenarios for different pollution sources, let's call it like this. So on one hand, we have a conventional monitoring system where seasonal monitoring is taking place, and then we observe the nature in pre-planned dates and times to try to come up with the reasons of a certain unexpected pollution events, which is a case during the past few months and years where most certainly authorities and responsible people cannot explain why certain events happened and what are the consequences of those events. So therefore we raise a simulation where we take into account event-based monitoring, and we want to press this change towards the perception of the monitoring itself, where we would like to develop a certain decision tree, as was presented in one of the keynote speakers' presentation, this nice mapping of the problem, where this decision tree would not only spark new questions for us as the researchers to answer, but also give us certain insights into the possible caution mechanisms to take. For example, it is commonly known that seasonal fluctuations between tourist flows is responsible for an increase in pollution from small settlements. We have this example of Nida, which is a mainly recreational settlement, and it is really affected by the increase and decrease of the population density. Therefore, the current wastewater treatment plant or this infrastructure is not capable to cope with these extreme events like weekends, like festivals, where the large amounts of pollutant is entering the lagoon system and is not monitored by the conventional monitoring method. So first of all, the goals for us is to have these nice, which we already had, these nice brainstorming sessions where we find different questions and research topics for us. We would like to stress the necessity of different approach towards the monitoring itself, where we do not monitor during the events or after events, certain time of after events, and we do not have a grasp on the pollution which those events are emitting, which we know from our research and our background that sometimes those event-based pollutions may serve up to 80% of the general pollution. So yeah, these are our goals and tasks for us to complete during this hackathon. And yes, we understand the ambition between our targets. However, you know, we like to ask questions and then come up with the solutions, and possibly by doing that, we can raise awareness in the decision-making sectors of Lithuania and the Baltic Sea region.
Okay, thank you. Thank you for the presentation. And let's move on to another team, Poor Ocean. Do we have Poor Ocean now?
Yeah, hi.
Hi. We can't see you.
Hello.
You, yeah.
All right. I'm gonna share the screen. Can you see it?
Yeah, we can. Perfect.
Oh. All right. So I'm not gonna use much time to. Yeah. So my name is Alena Stepanova, and I am presenting Pure Ocean technology. We are a startup that was born last year, providing a technology that's been developed for 15 years in Russia. Do you know that there are 20 million barrels of oil emitted into environment annually, causing over 10,000 accidents? While it's being collected from the surface, the oil tend to sink down, and it's about 60% of the spill off sinks down to the bottom, poisoning everything around. It remains, since the process is very difficult to clean up the bottom, it remains there for 30, 40, and more years, completely killing the flora and fauna of the water body. One of the examples can be, for example, Liepājas port, which has a ballast of left pollution from Soviet Union time. So main pollutants are of this presented information are shipping companies, ports, oil companies, factories. And lately, in the recent years, the regulations became much more stricter, and companies are obliged to clean after themselves. However, the solutions that are available at the market, they are quite complicated and expensive. So unlike the other solutions, Pure Ocean technology is able to clean up the bottom of the water body floor from oil, microplastic, and chemicals without any mechanical intervention, without excavating soil, without using any chemical or biological substances, and without causing any damage to flora and fauna. So our solution is very simple. It's based on the method of on the principle of flotation. So we pump air into sediments and force the pollutant molecules up on the surface, where we controllably and safely capture it and remove it. So our solution is unique because it's completely eco-friendly technology using low physics. It does not impact wildlife. It's actually quite beneficial to environment. Our solution removes 98% of the pollution from the bottom of the shoreline, and greatly speed up the rehabilitation of the wildlife. And the most important, it's a cost-effective and time-effective process in comparison with traditional available technologies. So our technology was validated twicely in Russia, so and proven amazing results, removing 98% of the pollution and lifting 157 tons of oil from the lake. So what are we looking for? Well, we are looking for a possibility to run a field pilot project in Baltic Sea or any water body where we can prove within European settings the effectiveness and cost saving of the technology. We are looking for financial support to around 200 to 300 euros for extending our technology to 200, 300 meters down that can be used at the offshore platforms for oil companies, because at the moment the technology is proven to be successful on the 20 meters, and we're looking for running a pilot on microplastic. Because it's been proven in laboratory, and at the moment we would like to do the file test. So we're looking for industry advisors, opinion leaders that can help us to understand the industry better. We are looking for connecting to decision makers on cleaning the water pollution. We're looking for information on existing solution for cleaning up the bottom and the cost of the services available in order to give our clients, potential clients, a better picture and comparison. And we're looking to access water utilization company so we can cooperate together on this issue. So our team consists of 2 entrepreneurs and 2 specialists that have developed the technology and have a very great knowledge about microbiology and water treatment, and the expert that's taking care of our development. Yeah, we're born in conversation reactor. At the moment, we are part of Climate Kick, the first stage, and supported by Altum. And we are looking for going further and implementing our technology in Europe.
Thank you for your presentation. Nice to see you. I mean, your readiness to go. So let's hope this hackathon will kick kind of your journey, and it will be faster. And let's move to the next team. I mean, we still have 2 to go, so soon should be over as well. So BioVala team right now, please join, and the floor is yours.
Hello, everyone. Can you hear me?
Yes, we can hear you.
And see, I guess.
Yes.
Yeah, so thanks for the host for selecting us, and I will try to do my best to make a presentation in 3 minutes, and I will try to share my screen, I guess. You can see it?
Not yet.
Not yet. Okay, wait a minute. This one.
No, it's okay.
Yeah. So let's start. Yeah, we are a biotech company from Lithuania, BioVala, and we are glad to be a part of this hackathon. And to start, the Nemunas River is one of the largest contributors of nitrogen and phosphorus pollutants in the region of the Baltic Sea. The delta of Nemunas, which contains the highest nitrogen and phosphorus concentration, requires an enormous complex of different technologies to reduce the leaching of contaminants. And instead, we propose to use an artificial phyto-islands in numerous places along the river banks. So, with the proper selection of the plant basements, phytoremediation can be successfully performed in phyto-islands. So, phyto-islands creates an additional habitats for water birds and micro ecosystems for fishes. Reduces algae growth since plants takes biogenic elements through aquaponics and water beds and fish feed on algae. And the microecosystem can be adapted to individual needs by using environmentally friendly bacterial strains. So the microecosystem of Phyto Island can be artificially controlled in that way. So about our team, our company is working, as I mentioned, with Phyto ideas for about 6 years. And we have a strong background in and competence in understanding phyto and environmental problems. So our dream is to create successfully working unit by 2021 to get patent and provide our service for the businesses and governments by 2022, and we hope to make a great impact for the clear future. So that's, I guess, that's all.
Thank you. Thank you for being quick, actually, and then presenting it.
Yeah.
Maybe just to summarize one more time, so what kind of help you would like to have from mentors from this hackathon?
Yeah, we would like to get help for entering the market, to making this like still idea to have a body, and yeah, so, and like everything best we can get, I guess, from this list of mentors as I reviewed. So the main thing is just to enter the market and make the impact to clear our future.
Perfect. So thank you, Žygimantas, and yeah, this is all the teams we have. So just to kind of end up in a high note. So first of all, I would like to mention that we have lots of organizations. We reach out more than 40 of them, and there are just some of them who already joined our hackathon, and some of them are joining yet, to support in any way, either with teams, either with kind of experts or jury or whatever. So you saw some of them today, and thank you everyone. I will not say out loud all the names because it will take me forever, and probably everyone is already kind of wanting to go and start with their projects. Just so, you know, just maybe at the last point, just to finish also with a high note, we want to show you a video, also a short video to inspire you and let it lead us till the end of the hackathon and even further until the implementation of all the solutions. So here's the video.
Because a lot of you won't remember this, but when I ran for the presidency in 2008, the truth is that not a lot of people gave me a chance. You know, I was a skinny guy with a funny name. When we started the campaign, the odds weren't for us, and we had a lot of states to cover, and I had never run a national campaign. And so we had to try to get any support we could, any endorsements we could. So I fly down to South Carolina. I go down to South Carolina for some state legislator's banquet or something, and I'm sitting next to this state legislator, and she hasn't made an endorsement yet. And I ask her for the endorsement. That's what you do when you're kind of trying to get support. And she says, you know what, Obama, I like you. You're a little young, a little green behind the ears, but I like you. I will endorse you if you come to my hometown of Greenwood, South Carolina. I go in, just fall out. Alarm goes off, and I feel terrible. I am exhausted. Think I'm coming down with a cold. I open up the curtains. It's pouring down rain outside. Pouring down rain. Horrible day. I make myself some coffee, and I get the newspaper outside my door and open it up. There's a bad story about me in the New York Times. I get dressed, shave, walk out, just kind of still groggy, still staggering. My umbrella blows open. That ever happened to you? as I'm walking out, and I get soaked. I'm just soaked. I get in the car. I say, all right, how long is it going to take to Greenwood? An hour and a half. An hour and a half. So we're driving, and we're driving, and we're driving. Doesn't seem like we're going anywhere. Sheets of rain are pouring down. So I'm about to make my pitch. I'm trying to muster myself up. Let me make the best of this. I'm going to do it quick, and then I'm going to get out of here. And suddenly I hear this voice from the back just shout, "Fired up!" And everybody in the room says, "Fired up!" And I say, "Ready to go." And then I hear the voice say, "Ready to go!" And everybody in the room says, "Ready to go." And I don't know what's going on. I think these people are crazy. Maybe I shouldn't have come here. And then I look in the back of the room, and there's this middle-aged woman, and she's dressed like she just came from church. She's got a big church hat, and she got, I think, a gold tooth. Turns out she holds a position in the local NAACP office, and also, I'm not kidding you, is a private detective. This is a true story. She's like a she's like a private eye. Although it's hard to think that you wouldn't see her coming. She's very colorful, and she's grinning at me. And apparently, she is known wherever she goes by saying this chant, "Fired up." And everybody knows her, so they know that when she says "fired up," they've got to say "fired up." And when she says "ready to go," everybody's got to say "ready to go." And this is what she does. Every meeting she goes to, she does this thing, which is kind of strange. So the thing is, though, she keeps on doing it. And everybody keeps on, she says "fired up," and they say "fired up," and "ready to go, ready to go." But the interesting thing is, after a while, I'm starting to get kind of fired up. I'm starting to feel like I'm ready to go. And all those negative thoughts and all those bad memories start kind of drifting away. And we have a great meeting with these 20 people. And they all say, "We're going to support you. And we're going to go out there and work." And even after we left Greenwood, the rest of the day, all the campaigning, when I saw my staff, I said, "Are you fired up?" They say, "I'm fired up, boss." "Are you ready to go?" I'm ready to go. And it just goes to show you how one voice can change a room. And if it can change a room, it can change a city. And if it can change a city, it can change a state. And if it can change a state, it can change a nation. And if it can change a nation, it can change the world.
So thank you. Thank you for watching it. And I really hope that you are fired up and ready to go. And I'm looking forward to meet all the teams, and in one-on-one meetings. So this is it. The first part of the hackathon is over. And yeah, talk to you and see you in the next rounds of this hackathon. So thank you all for your participation.
Thank you very much.
Ready to go.
Time to change.
Thank you so much. Thank you, Essie.
Thank you, everyone.
Thank you.
Talk to you later. Bye-bye.
Bye-bye.